Hello everyone, in this video we are going to discuss about the modulus and the conjugate of a complex number from the chapter 4 complex number and quadratic equations class 11 max. See, here we will be discussing about the modulus of a complex number as well as the conjugate of a complex number. Let us consider a complex number z is equal to a plus ib. Okay, we are considering one complex number z is equal to a plus ib. See, z is the complex number. Then the modulus of z is defined by, it is actually defined to be, modulus of z is actually denoted like this. Okay, it is denoted by modulus of z. This is defined to be the non-negative real number square root of a square plus b square. So the modulus of a complex number is defined like this. Modulus of z is equal to square root of a square plus b square. Okay, now the conjugate of the complex number z, it is denoted by z bar. Okay, conjugate of a complex number z is denoted by z bar and it is defined as a minus ib. Okay, so you see the complex number z is equal to a plus ib. Its conjugate z bar is equal to a minus ib. That is the imaginary part is just changed its sign. Okay, now modulus of the complex number, modulus of z is equal to square root of a square plus b square. Okay. For example, let us consider a complex number z is equal to 3 plus I. Okay, then its modulus will be equal to modulus of z is equal to modulus of 3 plus I. Okay, see here a is 3 and what about b? I b, no? So I into 1. So b is actually equal to 1 here. A is equal to 3, b is equal to 1. Okay, then modulus of z is actually defined as square root of a square plus b square, that is 3 square plus 1 square, that is square root of 3 square 9, 9 plus 1 10. Okay, so this is modulus of z. And what about the conjugate of the complex number? Conjugate of the complex number z bar is equal to 3 plus I bar. Okay, that is when we find out the conjugate, what we want to do, we just want to change the sign of the imaginary part. So this is 3 plus I, so we just want to write it as 3 minus I. Okay, similarly, let us consider another example. That is, let us take the complex number z as 2 minus 5y. Okay, then it's, the modulus of this number z can be written as, see here, when you compare this complex number with this a plus ib, here a is equal to 2 and what about b? Plus ib, so this is minus 5y. So I is there, what about b? Minus 5. So b is equal to minus 5. So modulus of z will be equal to square root of a square plus b square, that is 2 square plus minus 5 square. This is equal to square root of 4 plus minus 5 square is 25. Minus square plus 5 square 25. This is equal to square root of 29. Okay, and what about the conjugate? Z bar is equal to what? This is 2 minus 5i, no? So its conjugate will be what? 2 plus 5i. Okay. Now consider a non-zero complex number z is equal to a plus ib. Okay, now the multiplicative inverse of this z will be equal to what? Which we have already learned in our previous video. See, the multiplicative inverse of z is actually written as 1 by z. Okay, see 1 by z is equal to 1 by a plus I into b. Okay, I am just multiplying both the numerator and denominator with a plus ib. Okay, so this becomes what? 1 into a plus ib is a plus ib divided by a plus ib into, sorry, I actually wanted to multiply the numerator and denominator with a minus ib. I'm sorry, this is a minus ib. So a minus ib divided by a plus ib into a minus ib. See, this is in the form a plus b into a minus b, which is a square minus b square. So a square minus b is actually what? ib. So ib whole square. Okay, so this is equal to a minus ib divided by a square minus I square is minus 1. That minus and this minus becomes plus, then b square. Okay, So you see 1 by z is equal to a minus ib divided by a square plus b square. Now you see this can be written as a minus ib divided by, you see, mod if z is equal to a plus ib, then modulus of z, that is equal to root of a square plus b square. Okay, I'm taking square on both the sides. So modulus of z square is equal to a square plus b square. When we take the square on root, it becomes the a square plus b square itself, no? So you see this a square plus b square, that can be written as modulus of z all square. Okay, this is equal to, what about a minus ib? If z is equal to a plus ib, then z inverse, z bar, which is the conjugate, that is actually equal to a minus ib. Okay, so we can write it as z bar, which is the conjugate of z, divided by modulus of z all square. Okay, so you see, this is 1 by z. 1 by z can be written as z inverse, which is actually the multiplicative inverse of z. That can be written as z bar divided by modulus of z all square. Okay, now you see, this can be written as, I'm taking, you see, this is like 1 by z is equal to z bar divided by modulus of z all square. Now, I'm taking this, modulus of z all square to this side. So that goes to the numerator. Then I'm taking this z to this side. That also goes to the numerator. So we can write it as modulus of z all square is equal to z into z bar. Okay. So you see, we have seen that modulus of z square can be written as z into z bar. Z bar is the conjugate of z. Okay, similarly, for any two complex numbers z1 and z2, we have modulus of z1 into z2 is equal to modulus of z1 into modulus of z2. Then modulus of z1 divided by z2, that is equal to modulus of z1 divided by modulus of z2, provided modulus of z2, which is in the denominator, that is not equal to 0. Similarly, modulus of z1 into z2 bar, that is the conjugate of z1 into z2, that is equal to conjugate of z1 into conjugate of z2. Then conjugate of z1 plus or minus z2, that is equal to conjugate of z1, okay, plus or minus conjugate of z2. Then z1 divided by z2, the conjugate of z1 divided by z2, that is equal to the conjugate of z1 divided by the conjugate of z2, provided this z2 is not equal to 0. So in this video, we have actually discussed about the modulus of the complex number as well as the conjugate of the complex number. I hope you got some ideas about this. We will be discussing the exercise questions as well, which are available in the playlist. Thank you.